Hello, welcome back to my channel. In this video, we're going to talk about hydrocarbons. What are hydrocarbons? Hydrocarbons are organic compounds that contain hydrogen and carbon. Classes of hydrocarbon. Hydrocarbons are classified into 1. The aliphatic hydrocarbons, 2. The aromatic hydrocarbons. Aliphatic hydrocarbons are further classified into the alkanes, the alkenes, the alkyne, and cyclic aliphatic. Let's talk about the alkanes. So the alkanes are saturated hydrocarbons. That is, they contain only single bonds. The general formula for alkanes is CnH2n plus 2, where n is the number of carbon atoms. The simplest alkane is the methane, which has molecular formula of CH4 with 1 carbon atom. The met represents 1 carbon atom, which now is the prefix, and the N is the suffix, which represents all alkanes. We can use the general formula for alkanes to calculate the molecular formula once we know the number of carbon. In this case, it is 1. So if we substitute this 1 into the general formula, we get CH4. For ethane, which has 2 carbon atoms, the Eth is the prefix, which represents 2 carbon atoms. And the N, as usual, is the suffix for all alkanes. So if we join these two together, we have ethane, okay, which says 2 carbon atom alkanes. Now we substitute the 2 into the formula, we can get C2H6 as the molecular formula. The first 10 alkanes are listed on the screen. Now, note that all the colored ones, the ones in purple color, represents the number of alkane, those number in front of them. So when you see prop means 3 carbon, right? Carbon atom. But means 4 carbon. And so on. Pent is 5, hes is 6. So whenever you see all these prefixes, it's telling you the number of carbon that compound contains. Okay, so these are all the molecular formula for the first 10 alkanes, and you can calculate it using the same general formula that I mentioned earlier. Let's talk about alkenes. Alkenes are unsaturated hydrocarbon with double bonds, C double bond C, with general formula of CnH2n. The simplest alkene is the ethene with 2 carbon atoms, C2H4. We got this C2H4 by calculating using the general formula. Examples of alkenes are the ethene, the hexene, propene, heptene, and so on. Now also know that in this case, the purple marked colored ones are the prefixes representing the number of carbons. So when you see the butene, we're talking of 4 carbon atom alkenes, right? When you see, like for example, the 9th one there, non represents 9. Okay, so and we can go ahead and calculate the molecular formula now that we know what each of those words represents, right? So we know that the ethene is talking about 2 carbon atom. When we equate it to the general equation, we get the C2H4 and so on down to the 10th carbon. Also note that "ene" is the suffix for alkenes, that is ENE, which is different from the "ene" in alkanes that we saw earlier. So we have "ene," ENE, and in "ene" we have ANE. Let's talk about the alkynes. Alkynes are unsaturated hydrocarbons. Just like the alkenes, they are unsaturated. But the major difference is that these ones contain triple bonds. So you have a C triple bond C. And the general formula for alkynes is CnH2n minus 2. And the simplest alkyne is the ethyne with 2 carbons. So we can use the general formula on the screen, that is a CnH2n-2, to calculate the molecular formula once we know the number of carbon atoms that it contains. Like the Earth is telling us is 2, so it's easy for us to calculate that. Now we go to the propane, we go to the butane, so on until the 10th carbon. Now, just like the alkane and the alkene, the purple color represents the number of carbon that it contains. And also note that the suffix in this case is "-ine", not "-ane" or "-ine", as in the case of alkane and alkene. In this case, the suffix is "-ine". In the alkene, you have "-ine". So those are just the differences you will see, but the prefixes for the 3 of them is the same. And these are the molecular formula for alkynes that are listed here. And you can equally calculate it once you know what number of carbon you're dealing with. So here you have all of this with their molecular formula. Let's talk about cyclic aliphatic. Now, cyclic aliphatic can be cycloalkanes, it can be cycloalkenes, or it can be cycloalkynes. Now, note that this type of hydrocarbons are the ones that form a ring, okay? Their carbon form a ring. And the simplest cycloalkane will be the cyclopropane. You see that the propane still stands, prop for 3 carbon, and ane for showing you that it's an alkane, but in a cyclo form. So this is a cyclopropane. So the cyclo is what makes it different from the normal propane. Cyclo shows you that it's in a ring form, right? And that is the structural formula for a cyclopropane. It looks like a triangle. So each of those sides starts for carbon. So you have 3 sides. Comparing the 3 different cycloaliphatic, we have the cyclohexane. The cyclohexane has no double bond, whereas the cyclohexene have a double bond. And then the example for cycloalkyne, which is in this case a cyclooctane. The octane is showing us that it has 8 carbon, right? It has a triple bonds. So you see you have no bond, double bond, triple bond. Those are the differences. Let's talk about aromatic hydrocarbon. So when we talk about aromatic, we're talking about those that form a ring, yes, but the difference is that they have alternating double bonds. They have alternating double bonds. The other one we saw has no alternating double bonds, right? Their double bonds is localized. But these ones, their double bonds can be delocalized. So those are the difference between this and aliphatic, cyclic aliphatic. And the simplest one is this benzene, which you can see the alternating double and single bonds. Thank you for watching. This is the end of the video, and please don't forget to subscribe, and see you in my next video. Bye.